I think that's 200 dies.
Here, get another black eye. That hurt. So we have a couple of kind of purpose-built front ends, and so we love open and honest feedback too. If there's things that you see that aren't being collected on, I'll show you in a couple slides. There's about 2,000 metrics. Go.
Would this be similar to like Nagios or something?
I'm not familiar with Nagios. Tell me about Nagios.
They're an open source.
Are they doing both application level events and incidents, network, storage? Because if they are, then yep. And if they're
I don't
not,
know if they're correlating stuff, but basically it's an IT solution to basically monitor the whole enterprise.
I'd love to get the spelling of that because I'd like to check them out.
Nagios.
Oh, that's pretty easy. Nagios. Cool. You guys, is anyone else using Nagios? It'd be cool. I would go play around with it tonight. So the interesting thing I think from the standpoint of VDI is that there are definitely some showstoppers, and there's definitely some things that count more than others. I usually do, like, I was thinking of if I could do this whole presentation off one slide, this is the slide I would have picked. Because basically it's a lot of stuff and you can talk about a lot of it. But the theory here is also, if I'm thinking about doing desktop or application virtualization, I can focus on like any one of the light or dark kind of gray or blue on my screen elements here, and that counts in some way, shape, or form. Like what monitors and what resolutions are set at and what aspect ratios can completely make something a deal killer or a deal maker in terms of which remote display protocol you choose. Tim?
I'm assuming that your software wouldn't really be able to buy once the measurements are made. What are reasonable measurements for making decisions, right? You still need someone who can interpret this stuff?
So basically, we had a decision point, and I'll show you where we have this thing called VDI Fit and VDI UX, which are two composite metrics that we came up with. And to your point, we jokingly, maybe not jokingly now, but we have in our tagline, we're the art and science of virtualization, because you're absolutely right. Nothing can replace the gray matter that's, at least, well, mine can be replaced pretty easily, but yours, probably not. There still is thought that needs to go into it. So, for example, we can't build and anticipate an algorithm that looks at your observed values of what your users are up to and say, oh yeah, it needs to be on IBM blank class hardware with fiber channel storage, and here's the line and spindle configuration, and here's which part of the disk you should write to and when, and by the way, maybe that'll change over time. Because I think over time we're thinking we might actually help you make some of those decisions. But you're absolutely right. This is absolutely not a replacement for gray matter. If it's anything, it's probably a replacement or an augmentation of trying to make, or at least avoid bad decisions in a vacuum. That would probably be the best thing. I think it's interesting. There definitely are some showstoppers with VDI, but you'd be surprised how tolerant some of the systems can be. I mean, aside from that remote display protocol and the effects of the speed of light, I wrote a blog, I'm not sure if you had to read it, over the weekend called, they don't call them the suggestions of physics, they're the laws of physics, because they typically don't like to be challenged. But the point is that there are more tolerances in the architectures if set up correctly than I think a lot of us had previously thought. So I spent a lot of time on this slide because each and every one of these might have either today in a physical world, or what's another thing I guess we learned over time was we thought we'd be the absolute greatest solution for companies as they started thinking about exploring desktop virtualization. There's an awful lot of companies that just acquired the software to use for physical desktop monitoring. Some of them just because they wanted to improve their ticketing and help desk system. They didn't want to have to spend necessarily a ton of time reverse engineering or playing detective when someone called up and said something's broke or something's slow. They wanted to actually see the specific event and be able to kind of rewind time and say, oh, that was the bump, and there was the app, and there was the page fault level, or there was the I/O spike or something that happened. So that gets pretty cool. Oh, this was the metrics. So these are the two composite metrics that we came up with. Part art, part science, part voodoo. And the theory was this. The theory was we could definitely look at the provision and consumption of resources and use some knowledge in terms of some of the showstoppers and say, based on observation of your environment, the following users are fit for desktop virtualization, which means a ton of different things, as that one slide said. Conversely, there are other measurements that we can make when a system's running to say, well, your user's having a reasonably good user experience, right? That would be the UX. And the thought behind that was, if I could set a baseline, I mean, everyone in this room probably has a different tolerance for pain. The point at which you'll tap out and call someone for help. Mine's pretty low. So the theory is that if I could watch a user environment of 100 users or 1,000 proactively and preemptively, then I could watch deviations from baseline. Ooh, login times are starting to creep up a little bit, because I'm looking at this in aggregate, but of course I can hit any one of these bubbles and drill down to the individual user and system process. But maybe, just maybe, it would allow us to do things, more strategically and a little less kind of in fire drill mode. So instead of saying, okay, shoot, something happened, let me go see if I can figure it out and fix it, it was holistically, ooh, I've got some blinks happening over here in network, and I/O to shared storage is looking a little bit weird, or maybe one application specifically, that one we just patched, is taking a lot longer to load than it typically had been, or at least a threshold or an alert level that I set. Maybe that helps us, get through our days. And I guess it goes back to the kind of first bullet point, which was, does it or could it help us create more reliable computer systems out of all these parts that are just prone to failure, including users. When we get into virtual desktops, there definitely are a couple things that can blow up quickly. I like to call them, boot storms or I/O storms. It's just anything that overwhelms the storage fabric. The interesting thing is, when you think about server virtualization or desktop virtualization, the consciousness of the desktop or the machine lives up on the host, but its soul lives down in the sand, right? So you got to keep that healthy. So the point is that all those random reads and writes and all of the very apparent things and erratic and sporadic things that users can do to that virtual disk file, that counts, and it's not very predictable. And so our thought is that if you can have visibility into what's happening in real time, I can avoid what can potentially be somewhat painful. And vMotion, the ability to migrate running machines, is obviously wonderful stuff. But at the same time, maybe it's more of an app delivery issue. Maybe I need to separate my users' profiles out. Maybe that user profile on the C disk is just getting too big and bloated. Maybe it's something that if I could find a more elegant way to get it out of that machine, back it up, I'd have more recoverability, which would make me more reliable. Just a couple of screenshots, and you'll see this if you want to download the VM and play around with it. I'd love you to try it out. This is the user. I should just look at my screen. This is the user experience kind of dashboard where there'll be some UX tracking. So in the upper left-hand side, we'll track the user experience over time. You can track login delays or who's having the slowest login process or machine counts and users or application launch times. We also correlate all of this with host-based metrics. So it's not just what does Virtual Center think it's presenting up to the guests that are on top of it, but what's that OS think is happening inside of itself? Because sometimes Virtual Center will think, all is well and right with the world, and yet, you've got very crazy things happening inside of the guest. And so we think that's fairly important to watch. Another interesting thing is I can actually do some A/B testing. So let's say I'm thinking about doing VDI, right? It's still kind of voodoo to me, and maybe I even did an assessment, and I think I've got my architecture nailed. There's nothing that says I can't run the software on the physical systems from which I came, maybe even another sample set, and the virtual desktops that I just created, and do some simple A/B testing. What improved? What got better? Everyone told me that application response times were going to be quicker because, Outlook and Exchange were like a rack apart. That was supposed to be way faster than sending it out to, branch 415. Well, did it happen? And if it did happen, did it save you any time? Did that save you any money? I guess if there's not a huge business win in any of this stuff, I like playing around with technology like everyone else, but at the end of the day, if it doesn't solve a purpose, what's the point? We just start creating, I think, more work for ourselves. It's interesting. I have ADD really bad, so I'll go off on these tangents, but this is a pretty good one. Somebody the other day, or you maybe even have heard this, they're talking about, desktop virtualization or VDI in general. I just can't get the CapEx to work. I look at a $499 machine that I can buy from Tiger Direct, and I compare that to like a $1,800 virtual desktop on ESX or even Zendesktop, and I just can't get the numbers to work. And I'm like, well, what happened to typewriters? And they're like, what do you mean? I'm like, well, a typewriter was like this $200 thing, and it needed like one SKU to support it, maybe like the ribbon cartridge and a piece of paper. And then we threw those away over the course of like 5 years and went to this like $2,000 thing called the PC that needed like 80 SKUs to support it and had hundreds of moving parts and staff and tons of people to give it careful care and feeding. That you can't make the CapEx argument there. So why in the world did we migrate from typewriters to PCs? And I think, personally, it was the promise of productivity that this new thing, could give our end users. I could make a user more productive by spending that amount of money on that new piece of equipment, that new technology that enabled them to do their job. versus the typewriter. And I think a lot of people agreed, and it happened in a very short period of time.